Okay, for part 3, we now need to find where O to T intersects with P to Q. So this time for T, when we're dealing with T, we do need to have T or O to T as a vector equation. So same setup as last time, we need a position vector, which is a point on the line, but the easiest thing to use for that one is just 0, 0, 0, because we know that this vector equation goes through the origin. So I don't actually need anything here because I'm going to have 0, 0, 0. I just need to have plus I'm going to use S, a different letter, lots of the direction vector, which is the difference, if you remember for P to Q, it was the difference between the 2 points. Again, because one of the points that we're using is 0, 0, 0, we just need to use this vector here, 1, 2, minus 1. So, in order to find the point of intersection of two vector equations, we need to equate the x components, the y components, and the z components. And we need to find out the value of s and t that make all 3 equations equal to each other. So in order to do that, usually we pick 2 at a time, take 2 of them, and this time I'm going to use 1 and 3 because they've got the same coefficient for s, they've just got different signs. So if I add together 1 and 3, that will make the s's disappear, and we're going to have 5 plus minus 9, which is negative 4. That shouldn't be an equal sign, that can be an arrow. Minus t plus 3t is plus 2t, and that's going to equal 0. So that tells me that 2t is 4 and that t is 2. If we know that t is 2, we can find out what s is. S is going to be 5 take away 2, so s is 3. And we can then, well, we should really check if that works for equation 2. If we put in 3 and 2, do we get the left side equaling the right side? So here we'd have 2 plus 2 times 2, and on the right hand side we'd have 2 times 3, and that does work. That gives me 6 on each side. So that tells me that they do intersect, and that they intersect when t is 2 for P to Q, and when s is, I didn't write it down, when s is 3 for O to T. So to find the point for which they intersect, I'm going to just substitute 3 into here. I could substitute 2 into here, but this was obviously going to be quicker, and say that the point of intersection is going to be 3 lots of 1, 2, minus 1, which is 3, 6, minus 3. Notice there I've given it as a vector. It says find the position vector of the point. So it wants it as a vector rather than a coordinate. So that is my final answer.